acceleration due to gravity and terminal velocity. In this module, you will learn about acceleration due to gravity. Gravity is the property of nature, in which each body attracts another body with an equal but opposite force, like the Earth attracting all bodies. You'll therefore first be learning about acceleration due to gravity before you can understand terminal velocity. You may have noticed that an object falling towards the ground comes down with its speed increasing every moment. All free-falling objects experience acceleration due to gravity, which is equal for all objects in magnitude and always directed towards the Earth's center. Acceleration due to gravity is thus a vector quantity. When you drop a pebble from a height, it falls towards the Earth due to Earth's attraction. You'll find that in such a case, the pebble will move down with a velocity increasing uniformly with time. That is, with acceleration. Air or any other medium, due to its resistance, opposes the fall of these objects through which they move. This helps them to reach a constant terminal velocity, reinforcing Newton's law of motion. If you throw down a marble and an iron ball from equal heights, which of the two will reach the ground first? They will both take equal time to come down. Do you know why? Here is the explanation. Galileo was the first to explain the science behind this observation. He proved that all freely falling objects are subjected to a constant acceleration due to gravity because of Earth's attraction. This acceleration being a constant, g is equal to 9.8 meters per second square, affects both the marble and the iron ball equally. As a result, both accelerate equally and therefore take equal time to come down and hit the ground. The uniform acceleration of a freely falling object due to the gravitational attraction of the Earth is known as acceleration due to gravity. For freely falling objects close to the Earth, this acceleration is constant, that is, g is equal to 9.8 meter per second square. It does not depend on the mass, shape, or size of the object. Galileo's experiments were true, but only for a freely falling body. If you drop a marble and a feather from an equal height in air, the marble reaches the ground first. If, however, the same experiment is conducted in vacuum, both will hit the ground together. The type of motion in which the only force acting upon an object is gravity is called a free fall. This happens only when other forces besides gravity are absent, like in vacuum. Let us closely follow the motion of a freely falling feather and a marble in the absence of any opposing force, like resistance due to air. You'll observe that due to gravity, both the objects move with a uniform acceleration of 9.8 meters per second square, and irrespective of their weights, their velocities increase with the same rate. Let us draw the velocity time graph of the object falling in vacuum. You will find this graph linear and its gradient positive, thus showing the acceleration to be positive. Thus we conclude that in the absence of air, a freely falling object achieves a uniform positive acceleration, which experimentally is equal to 9.8 meters per second square. When a feather and a marble are dropped from a height in air, why does the feather go down with a slower speed? This is due to the air resistance opposing the feather's free fall. Both the falling objects encounter resistance due to the frictional force between these objects and the air molecules. This air resistance opposes the downward motion of these objects and thus slows their downward velocity. If the air resistance acts on both the feather and the marble, can you tell why don't they fall with an equal velocity? This is because the air resistance increases with the speed of the object, the surface area of the object, and the density of air. That is, it's different for different objects. Thus, though the acceleration due to gravity is same for both objects, marble and feather, as the net force between the weight and the air resistance for the feather is more and negligible for the marble. Hence, the air resists the fall of feather more than that of the marble. So, the feather falls with a lesser speed than that of the marble. Let us follow the motion of a skydiver in air. As the skydiver falls, his speed increases because of acceleration due to gravity. But any increase in velocity results in an increased air resistance acting in the upward direction, which is called the drag. This increase in air resistance negates the downward attraction due to gravity or the skydiver's weight, resulting in acceleration less than due to gravity. As the skydiver continues to fall, at one point of time, the upward force due to air resistance becomes equal to the attraction due to gravity or the weight of the skydiver. Since the forces are balanced now, the net force becomes zero and the skydiver stops accelerating. At this stage, the skydiver begins to fall with a constant velocity. The velocity at which the skydiver stops accelerating is the maximum he could achieve. This velocity is called his terminal velocity. From this point onwards, the skydiver continues to fall down with this maximum terminal velocity, which remains constant. You have thus observed that a small and heavy object take a longer time to achieve terminal velocity, while a light object or an object with a large surface area takes shorter time to achieve terminal velocity. Thus, terminal velocity depends on the weight, shape, size of the object, and the nature of the medium in which it falls. Let us sum up the motion of a skydiver in air and trace his velocity time graph. From the time he falls, it is observed that the velocity of the skydiver first increases up to a certain time, then the rate of change of his velocity decreases due to increased air resistance, and finally his velocity reaches terminal velocity and remains constant after that. Let us discuss two interesting applications of terminal velocity: skydiving and parachuting. A skydiver in the spread eagle position has greater cross-sectional area than a skydiver who falls feet or head first. This increased surface area of the skydiver helps them to reach a lower terminal velocity. The same applies in the case of a parachutist when his parachute opens up. In this module we have learned the Earth attracts all freely falling objects with a constant acceleration, which is called acceleration due to gravity, g. Acceleration due to gravity is equal for all objects irrespective of their shape, size, or weight. Acceleration due to gravity, g, is equal to 9.8 meters per second square for all objects relatively close to the Earth's surface. The type of motion in which the only force acting upon an object is gravity is called freefall. In the absence of air resistance or resistance of any other medium, all objects fall under gravity with constant acceleration. When there is air resistance, a freely falling object experiences decreasing acceleration till it reaches a terminal velocity. Terminal velocity is reached when the force of air resistance equals the weight of the object. After terminal velocity is reached, objects fall with constant terminal velocity.